we discuss about the 18th group element. Group elements. We discuss about the 18th group elements. 18th group elements: helium, neon, argon, krypton, xenon, radon. General atomic number of 18th group elements: helium 2, neon 10, argon 18, krypton 36, xenon 54, radon 86. Next, atomic mass. Atomic mass: helium 4, neon 20, argon 40, krypton 84, xenon 131, radon 322. Next, general electron configuration. General electron configuration into ns2 np6. Here fulfilled of the orbital except helium. Helium generally 1s2. Neon, helium 1s2, 2s2, 2p6. Argon, neon 3s2, 3p6. Krypton, argon 3d10, 4s2, 4p6. Xenon, krypton 4d10, 5s2, 5p6. Radon, xenon 4f14, 5d10, 6s2, 6p6. These are the electron configuration of 18th group elements. Next, generally 18th group elements outermost orbital. Totally how many electrons? 8 electrons. So valence electrons 8 electrons. So it is called as the stable electron configuration. It is the monoatomic gases. Okay. 18th group is also called as noble gases, inert gases, and zero group elements. Rare gases. So these are called as the 18th group elements. Next, generally atomic radius. Atomic radius generally top to bottom increases. Atomic radius top to bottom increases. Helium greater than neon, argon, krypton, xenon, radon. Generally top to bottom increases. Next, to ionization enthalpy. Or energy. Top to bottom ionization also decreases. Atomic size increases, ionization energy decreases. Helium greater than, neon greater than, argon greater than, krypton greater than, xenon greater than, radon. Generally electron affinity. Generally electron affinity top to bottom decreases. So here one exception is there. Helium is very less electron affinity or electron gain enthalpy. Here most neon is greater than, argon is greater than, krypton is greater than, xenon is greater, neon, argon, krypton, xenon is greater than, radon is greater than helium. Helium is the small electron gain enthalpy because of small size. So new electron entered into the same new electron entered into the p orbital. So here electron repulsion is more between the new electron entered into the p orbitals and present in the p orbital electrons. Next to density. Density generally top to bottom mass increases, density also increases. Helium less than, neon less than, argon less than, krypton less than, xenon less than, radon. Next to melting point. Melting point and boiling point. Next to melting point, top to bottom generally increases. Helium, neon less than, argon less than, krypton less than, xenon less than, radon. Boiling point. Boiling point generally helium less than, neon less than, argon less than, krypton less than, xenon less than, radon. Here noble gases were placed between, noble gases were placed between, noble gases were placed between, noble gases placed between halogens and alkali metals. Halogens means high electronegative non-metal atoms, and alkali metals means high electropositive metal elements. Noble gases placed between. Next to oxidation state generally noble gases is zero oxidation state noble gas because of the fulfilled stable electron configuration. So next to argon is cheapest noble gas. Argon is the cheapest noble gas. And argon most abundant noble gas. Argon most abundant in noble gases. Except to radon, other noble gases occurs in the free state in universe. Except to radon, other noble gases occurs in free state, in universe. Next to noble gases are generally colorless, odorless and tasteless. Noble gases are colorless and odorless and tasteless. These are the noble gas physical characters. Next, easily liquefaction of noble gases increases from helium to xenon. Easy of liquefaction of noble gases increase from helium to xenon due to increase of the van der Waals forces. Easy of liquefaction of noble gases increasing from helium to radon due to increasing van der Waals forces. Generally increase the van der Waals forces. Next to helium, low boiling point. Low boiling point means 4.2 kelvins. Becomes liquid. This is the helium 1. And further cooling 2.2 kelvins. It's low viscosity. Low viscosity. So it is the helium 2. This is also called as superfluid liquid. So this is called superfluid. This is the most important. Superfluid. Next to helium and sometimes neon also found in minerals of radioactive origin. Example, Blichbend, monazite and cleveite. Helium and sometimes neon are found in minerals of radioactive origin. Example, Blichbend, and monazite and cleveite. Helium and neon are found in minerals of radioactive origin from the Blichbend, monazite, cleveite. And xenon and radon, rarest element of the gases. Xenon and radon, rarest element of the gases. Next to radon is obtained as a decompose of the product of radium. Example, radon is obtained. Radon is obtained as a decomposed decompose of the product, product of radium అంటే 22688. okay, radium 22688 decomposition, then we get the radon 22286 plus 2He4. you obtain from the decomposed of the product of radium. Next to chemical reactivities. Chemical reactivities, generally noble gases do not involve in the chemical reactions. Noble gases do not involve in the in chemical reactions. Noble gases do not involve in the chemical reactions. Some compounds involved in the chemical reactions, but specific conditions. Some compounds of noble gases, noble gases have been prepared under special conditions. Generally noble gases do not involve in the chemical reactions but fulfill electron configuration. And some compounds of the noble gases have been prepared under the special conditions. And in these noble gases, helium and neon does not form the chemical reactions, chemical compounds or reactions, chemical compounds. And the reason due to absence of vacant or empty orbitals. Next, even though argon has empty orbitals, but shows a very low chemical reactivity due to presence of higher excitation enthalpy. Even though argon has the empty orbital, but to low chemical reactivity, but very low chemical reactivity. Very low chemical reactivity due to higher excitation enthalpy or energy. Next, Next, krypton and xenon have the empty orbitals and low ionization energy. Exhibit the krypton and xenon exhibit the chemical reactivities. Krypton and xenon, low ionization energy and empty d orbitals for excitation of electrons from p orbital. So it exhibits the chemical reactions. Here krypton limited from the chemical reactions. For example, krypton exhibit the limited compounds. Krypton exhibit the limited compounds. Krypton difluoride, krypton tetrafluoride. This only. Next, first in this the noble gases of first chemical compound prepared by the Berthollet, that is the xenon platinum hexafluoride. First chemical compound of noble gases. First chemical compound of noble gases was prepared by Berthollet. Berthollet is xenon platinum hexafluoride. This is the first prepared of the noble gas compound. Next, xenon forms more number of compounds with fluorine with oxygen.